Good morning, and welcome to Cloud OnAir. So today we are offering you a journey, actually, from big data to artificial intelligence. So we will have great speakers in this keynote and a great selection of workshops and sessions around three main tracks. So I have a chance to meet a lot of organizations and travel a lot across Europe, Middle East, and Africa. And there is really something that is trending right now. I see more and more these organizations to focus on three main areas to solve their real business issues. And these areas are logically actually people, processes, and technology. So it's absolutely critical to have very solid processes and the right technology today to drive your digital transformation. But also it's not only about technology, it's really about be able and capable to think differently about a specific problem. So those organizations which are leveraging these new technologies will definitely differentiate from their competitors. And it's now becoming totally crystal clear. The more you're going to leverage this technology, the more you're going to bring innovation into your organization that will drive you to creating new services and products to your customers that will really differentiate from your competitors. So no matter who you are in this organization, which level you are, which department you belong to, you are a catalyst actually to fuel the power behind the technology. But we really believe that the more we talk to business people in this organization, the more we think that data and machine learning and artificial intelligence will be the key differences again to drive your business forward. And this is really a principle that we have applied in our organization Google, where there is not a single process or product or service that we are building that is not backed with machine learning and artificial intelligence. And for that, not only we are bringing technologies into your hands, but we have created a partner ecosystem that is available to help you transforming a big idea into reality. And as an example, I wanted to share with you an amazing story that we have recently run with one of our partners and customers, which is Rolls-Royce. And Rolls-Royce came to us with an amazing idea to make autonomous ships a reality. So not only we develop actually technology for self-driving cars, but with the partnership of Rolls-Royce, we are now turning gigantic ships into fully autonomous ships in the sea. So let's hear from Carno Tenovuo from Rolls-Royce Marine Digital and Systems to tell us more about this amazing project.
The mission is to make autonomous ships a commercial reality. When we originally set out to do that, we thought that it would happen a bit later, at 2025-ish. Now we see that the market disruption is actually happening much faster. And we need to take into account many activities. So we start from the intelligent awareness, basically giving the eyes to the vessel. We are also working on connectivity solutions, so transforming that the data from ships to shore. We're building remote operation centers. So basically the infrastructure that you need in order to operate vessels from shoreside and monitor them. And then we're developing autonomous systems, starting from navigation systems, but also then later on moving into machinery systems. So basically covering the whole vessel that will be made autonomous one by one. We're looking to basically automate the data flow from sensoring to data warehousing to annotation and then to machine learning models and training the models. And we're looking to automate that data flow, and really Google is the best partner for that. Autonomous ships will affect basically safety, reliability, and efficiency. Those are the three main drivers: safety, reliability, and efficiency. That is basically driving the whole development. On safety side, you will have a lot of accidents that are happening today are happening for the crew on board the vessels. And now we can save a lot of accidents from happening when we're actually moving the work to shore side, or then making that work more automated in the future. So that is one thing. And of course, reliability comes that there's a lot of breakdowns today. The systems on board the vessels are not reliable, so they have to do a lot of maintenance while in operation today. In the future, when the systems are more autonomous, they also need to be more reliable. So there isn't so much need for the kind of maintenance work that you have on board the vessels today. And then on the efficiency side, you can of course now have the same team of experts sitting in a good office environment, supporting multiple ships or tens of ships, instead of having technical expertise in each of the ships. So the work is the same, but now more efficient. We can already use a lot of solutions that have been created for other industries in the machine learning space, and we can now apply them to change the shipping world as well. There's a lot of things we haven't done yet, so we need to, for example, create now the machine learning models and train them for marine use. We need to basically gather the data so that we can train the models also, for example, in nighttime and different weather conditions and different viewing angles. That kind of data set we need to create so we can have the best models out there. In ships you have a wider area to cover. We're using LiDAR, we're using radar, HD cameras. They have to cover so wide area because there can be very unpredicted movements of a lot of vessels. That requires a high computing power on board the vessel, and the good thing is that they have a bit more time to do the analysis, for example, compared to cars. Some of the Google Cloud technologies we're using include, for example, TensorFlow processing unit that we can have on board the vessels. You have data jobs, you have Hypertune, and then data labs. Those are the tools that have and solutions that have immediate benefit for the autonomous ships. Key takeaway is basically speed and flexibility to bring this to the market fast. So don't try to do too many things in-house. Partner, use open platforms and collaboration to drive this innovation fast.
So Rolls-Royce is just one example of so many new use cases that we are seeing, either actually from digital native, like very famous companies like Spotify, who is using this technology to change the way we are consuming the music by customizing and personalizing our experience. But also very traditional companies that are leveraging these technologies to build some IoT projects, for instance, like Philips, who is using Google technology for their web product, or Schlumberger in the oil industry, or Airbus, which is using this artificial intelligence and big data technology in their digital imagery business. It's super exciting. Technology is changing much faster than ever. And with that, it's creating an immense new panel of opportunities. It's amazing to see everyday customers and partners coming to us with net new ideas that they couldn't even think about a few years ago. So with that, today you will hear a lot about this use case, about these opportunities that either has been revisited with newer technology or just been created absolutely from scratch, as I said, because they just couldn't be implemented in the past with the traditional technologies. So you will hear our expert talking about big data, artificial intelligence, and industry solutions to solve their business problems. So once again, we are very excited to host this meeting. We hope that you will hear and learn a lot from these experiences. And let's start the journey. Thank you.
Thank you everyone for joining. We really appreciate your time today. And I want to talk to you a little bit about what is AI, how can it be useful for you, and what we're doing to help bring that technology to you. So let's start with the question of what is AI. It's interesting because AI is actually not a new concept. This is something that first made its way out there in the 1950s and has progressed really ever since then into kind of newer and newer technologies. But what we've really seen within the past few years is really a renaissance in AI. We've been able to actually really make use of the technology to really bring useful applications to people. And what's really made that possible is large computing resources and large amounts of data. And that really kind of changes the paradigm and changes how we think about how to program computers. If you think about how do we program computers, before, what we would do is we would give the computer all of the rules that it needed to be able to do what it needed to do, and then we would run a program. And AI twists that on its head. What it actually does is it learns from data. And in fact, it gets it wrong for a while, but then over time, as it sees more and more and more, it'll get it right and actually be able to predict and look at things that we may not have been able to look at before. It reminds me kind of where we are of where the internet was in 1994. And think back to kind of the first time you saw a web browser. For me, when I first saw that, you could start to see the promise of the internet and the kinds of things that it could do for me as an average person. For me, it was sports scores. All of a sudden, I could get sports scores right away. And then you could start to see things like being able to get news right away, being able to purchase things online. You could start to see that the internet was going to be a big thing. We're really in that moment for AI. We're starting to see amazing applications that are going to make this really relevant for everybody out there. And what I want to tell you about is how this is going to be relevant for you. So one common question that we get from a lot of our customers is, I know I should be using AI, but why should I be using AI? What kinds of things will it be able to do for me? So a few of the things where we're starting to see AI and machine learning really start to apply is kind of in these four areas. Personalized customer interactions. How can we make it such that every customer that walks into a store or walks into your office feels like they're having a personal interaction with you and you know them extremely well? This could be everything from, for example, being able to infinitely scale your customer service resources, or making it such that when somebody comes to an e-commerce site, they're able to get solid recommendations of what to do next. Things like that that are kind of taking that step to really knowing the person. But then you could start to take it even further than that. An example of this is Ocado, which is an online grocery in the UK. They're using some of our technology to be able to take a look at incoming email and figure out if a customer is angry or happy. And if it's an angry email, they're able to then escalate it and make sure that they get service to the customer very quickly. Efficiency and agility is another big area. What we're starting to see with this is that customers are looking at this and really figuring out how to make their infrastructure more efficient. We use this within our own data centers, and we've used machine learning to save 40% on our cooling costs just by optimizing how we use resources. And we're seeing that in areas like oil and gas, for example, or in things like industry controls. Being able to optimize how you use your equipment, and also be able to do things like predictive maintenance, for example, too. A third area is spotting patterns. How do we find patterns out there that'll help us actually figure out what to do? A great example of this is Rolls-Royce Marine is using our technology to be able to spot obstacles in a sea route and be able to navigate as a result of that. And this is just one example. There are many places where artificial intelligence can spot patterns where we may not even see the patterns. And the last thing is really adding structure to your data. Over 90% of the data that's out there within the typical enterprise is unstructured data. And so how are you going to find information there, and how are you going to figure out what type of information is out there? This is another place where AI and machine learning really resonate. Box is using some of our technology, for example, to be able to let a customer put their images into our algorithms and be able to categorize those images and find information and metadata about those images. And that makes it so that people can actually have a better understanding of what images they have. So the second big question that comes up is, okay, I know about machine learning, and I know what I want to do, but why should I use Google? And I'm going to take you through kind of our journey here. So first, let me describe to you a little bit about what we mean by AI and machine learning. AI is really kind of this concept of how do you actually roughly mimic the kinds of operations that we have in the human brain to be able to perform actions. And machine learning is one of the most promising techniques for doing that. And the way we do it is by actually having what is known as a neural network, where we mimic the neurons that are there in the brain, and then we have layers of them. So the output of one set of neurons fits into the next one, which fits into the next one, and arrives at a decision over a set of layers. And so an example of this is this picture. So if you look at this picture, any of us that look at this will recognize that this is a dog. But if you think about it, it's actually kind of tough to figure out, is this a dog or is this something else? But we know, we've seen dogs so often that we know that it's a dog. So when this goes through the network, what we're doing with the computer is that we're feeding it. It tries to use a set of algorithms to categorize it, and then it comes out with whether or not this is a dog or a cat. And a lot of times it's going to get it wrong initially. But what we do is we learn from that, and we feed it back in to be able to say, no, this was actually not a cat, this was a dog. Or we feed in other images that we know are images of a dog, and that makes the network smarter and smarter and smarter, to the point where it can very quickly recognize a dog. So imagine doing this over millions of images. At that point, you get to the point where it is very clear how to spot a dog from a cat. And so then you can get to very, very high accuracy. And this is just one example of this. And the amazing thing here is the computer was not trained at the beginning or didn't know how to think about a dog versus a cat. But now it actually is able to figure that out. So to us at Google, this really is a paradigm shift. This is more than just a tool. This is actually a new way to think about computer software. And we've really adopted it to the point where Google really is an AI company. And so if you think about our journey, if you look back, say, 3 years ago, we weren't really using much in terms of AI. But now what we're doing is you can see AI being used across many, many projects throughout the company. And so you can see on this graph, just over the course of those 3 years, we've gone from just a few hundred projects at Google starting to use deep learning, now to almost 7,500 projects within Google that are using deep learning. And in many of the products that you and I recognize, things like Android, things like Gmail, things like YouTube, we're using it in more and more ways to really help our users do what they need to do. And what we want to do now is make it such that it's possible for you to use the same technology that we've built to solve your own problems. And so the goal of our team here with Cloud AI is to make AI easy, fast, and useful for enterprises and developers. And let me dig into that a little bit. Easy, meaning that we want to make it so that anybody that knows how to use code can use AI. And so all of your developers out there should be able to use AI. Fast, we want to make Google the fastest place to run AI. Computing power is paramount here, and we want to make it so that you know when you put your workloads on Google and your AI workloads on Google, you're putting it in the best place. And useful, we want to solve real business problems with you, things that are going to actually affect your bottom line, and make it so that this is more than just something that's interesting, make it something that is actually business critical. And so the advantages that we have in AI are things that we're now passing on to all of our users. Our scale, we can bring to you thousands upon thousands of servers to be able to process these. And as we talked about at the beginning, really the reason AI has been so useful now is because of the amazing computing power that's now available in the cloud. The second thing is speed. We've really redesigned our infrastructure over the past few years to optimize it for machine learning. And what we're now doing is providing that same infrastructure to you as well, too, so that you have the most optimized infrastructure. The third part is the technology. We've now brought to bear all of the technology that we have internally around AI and are providing it to our customers. This includes TensorFlow, which is our deep learning framework that I'll talk a little bit about that we've now open sourced, as well as AI building blocks. And what I mean by this is we've taken a lot of the best AI models that we've built internally and we now provide them to you as APIs. And the last part is ease. So we provide a set of developer tools that make this easy for you. And then we also have programs like the Advanced Solutions Lab, which will make it so that we can work with you more closely so that you can learn from the experts at Google on AI. So the technology stack looks really like this, kind of from the bottom to the top. And it starts with our cloud and the scalability that we have with our cloud to be able to scale over thousands of servers. And then all goes up to how we design our servers. And so what we've done is from the silicon up, we've designed our servers to be optimized for AI. And we do this with a concept called the Tensor Processing Unit, the TPU. And we're now providing that with Google Cloud. And I'll talk a little bit about that in just a minute. But this gives you an amazing advantage in terms of performance. On top of that, we have TensorFlow, and that is really our framework by which we implement deep learning and implement a lot of the algorithms that we have. What we've done with Cloud is that we've given our users a set of development tools with Cloud ML Engine and Data Lab, which make it so that you can start to develop your algorithms, and you can start to not only do that, but bring in data from other areas and make your algorithms better and better and better. We have the AI building blocks that I mentioned, which are APIs to some of our best models and making it so that you're able to utilize a lot of the things that we've spent years developing. And then lastly, solutions and customization to make this really optimized towards your particular business use case. And so we're now starting to get into things like this, and I'll talk about some of the things that we're doing here. In addition to the technology, we have the community around it to make it so that this can become relevant to you, and you have people that can help you along the way in the journey. We acquired a company called Kaggle recently, and Kaggle has 1.2 million data scientists out there that are able to work with you on interesting AI problems and interesting machine learning. In addition to that, we have a community of partners that are able to work with customers to be able to implement this as well too, or have implemented this into their own applications as well. And by using this community, you can more easily bring a lot of these technologies to your set of users. So we think of AI really in three areas: the infrastructure, these building blocks, and solutions. And I'm going to talk through each one of these. So with infrastructure, it starts with Google Cloud. It really starts with the storage of the data and your ability to get to that data. And we're going to talk a lot more about our data tools that will allow you to bring in data from many different places and analyze that data, and then also bring it into machine learning. It goes to the compute, being able to use thousands of cores, GPUs, TPUs to be able to do these jobs. It then goes to the models, being able to actually build these models on top that can actually scale. And then once you have those models, being able to put it into a production workload and serve a high throughput to be able to put this as part of your mission critical applications. At the silicon, we've implemented what we call the Cloud TPU, as I was mentioning before, and we've custom designed the silicon to be able to be efficient for TensorFlow in particular. And we get an amazing 180 teraflops of performance out of these chips to be able to really exceed what's available out there right now in terms of speed. We provide Cloud ML Engine on top of that. And what this does is a way by which you can take your model, be able to upload it to Google Cloud, and have it be able to go through the various stages of the life cycle and then scale. So this allows you to do things like training and then productionizing and online prediction with your models. But then it also allows you to do things like, for example, do tuning of your model, things like hyperparameter tuning, and then figure out what kinds of these accelerators do you want to use. When do you want to use CPUs versus GPUs versus TPUs? We provide a visualization environment on top of that as well, too, so that you're able to interact with that and be able to try it and test it and make it better and better and better through a tool. TensorFlow is what this is all based on, and this is now the #1 repository for machine learning in GitHub. And this has become more and more and more popular over the course of the last couple of years that we've had this out there. We're going to continue to add to this as we develop great things here within Google, so that we can share that with you. And the interesting thing about TensorFlow, because it is open source, you have portability of these models. You don't just have to run that on Google's cloud. You can take this and run them in a variety of different places. You can now take it and run it on devices like a cell phone. You can now also take it and run it on-premise as well, too. And so it gives you that ability to really move around and be able to use your model where it's most needed. So the next layer here are the AI building blocks, those APIs that we have to great applications that we provide. What we've really done here is we take a lot of the fully trained machine learning models that we have, some of the things that you're familiar with a lot of our consumer applications, and we provide APIs such that you can use it. And we have a set that's already out there, and you're going to continue to see us add to this and bring, as we have more great technology, bring that to you. So a few of the examples of what we have here. Image recognition. Think about what you see in Google Photos. We can now take in an image and tell you metadata about that image. What kinds of objects are in that image? If it's a picture of a piece of text, we can actually tell you what that text is and actually convert it to text. If it's a picture of a face, we can tell you if that person is happy or sad, or tell you the emotion of that person as well too. So things like that can really kind of give you a handle of the images that you have. We've now taken this to video, and you could do similar types of object detection, but in addition to that, you can do things like scene transitions and understand kind of where there are transitions in scenes within a video, and various other things as well, like, for example, explicit content detection as well. Many people know Google's strength in things like machine translation, and we are now able to actually bring that out to our customers. But then also things like natural language processing, where you're able to put in a piece of text. We're able to detect the entities within that text and be able to give you an idea of the structure of the text, what that text is about, and how you can use that. And of course, Google is known for our speech recognition with things like Google Assistant, and that's now available as an API as well, too. Now we're actually going even further and starting to customize this for particular solutions. And recently we released what we call Dialogflow Enterprise, which is a way by which you can do things like build chatbots and build conversations so that you can be able to interact with your customers, or have something that interacts with your customers to be able to diagnose a customer's problem before it comes to, for example, a call center. And so things like that really let you scale. So to wrap it up, really kind of, we want you to be part of this vision, to be able to bring this technology to you. And we already have 10,000 plus customers that are working with us and a variety of partners, and we're looking forward to working with you to make this a reality. So with that, I'd like to introduce William Van Bennep, who leads a lot of our data products and can tell you about how you can bring your data in to these algorithms.
Thank you, Rajan.
Thank you.
Thank you. Thank you all for joining us. I'm William Van Bennep, and I lead the product management team for big data services on Google Cloud Platform. And as Rajan was describing, AI is really about data. And that's also what analytics is about. And so the two are really complementary and work on the same business data. And so to really benefit from AI, you also have to have the kind of control on your data that analytics provides, which means that you need to be good at analytics to be good at AI. And while that may sound like a somewhat negative statement, that's actually a positive. That's a chance. Because what it means is that the work that you put into analytics is something that directly can be leveraged into your adoption of AI. And so it's really not two parallel tracks. It's one continuous set of tools that allow you to derive value from data. And so let's talk a little bit about analytics and what it takes to get access to your data and what value you can get from it. And quite often, it seems like the equation is reversed, where it's not your analytics system working for you, it's really you working for them. And that's just wrong. And that's just what has been stopping a lot of companies from using analytics productively, and what has led to numbers such as those on the slide here that show that a very small portion of all the data, most of it is unstructured, as Rajan said, a very small portion of it is actually used productively. And even within structured data, we're quite far from being able to productively use all the structured data that is relevant and available. And so that's something that we've worked hard to change, initially just for Google own use, and now something that we're bringing to all users on Google Cloud Platform. And some of the main ways in which we've worked to provide that, one is by driving from the start very strongly on a serverless model. Even before the term serverless was used in that context, we've driven really hard to make all our analytics products available in that way, which I'll describe in more details. We're also standardizing on streaming by default, as opposed to a batch-oriented model, which obviously has its place, and we'll talk more about how we went about that. We've also incorporated the best of open source and brought Spark and Hadoop and other open source tools, some of which that Google contributed, like TensorFlow, and others from the community, make sure that they run really well on Google Cloud Platform, with the goal, once you have all that data, in addition to analytic system, to be able to use that with the AI systems that Regent described. So let's go back to serverless. What is serverless? In this context, serverless, the term now is used really to represent the fact that a lot of the infrastructure management and setup that you normally have to do on a big data system can be taken away and handled by the cloud provider. Now, there's no magic. There's still physical servers and network and cooling and software. Those things don't go away. What's different is that as a user, they're not your concern. And that the cloud provider, Google in this case, is the one doing that, which is great because that's something that Google is really good at. That's something we've been doing for a really, really long time. And so it works very well in terms of user productivity to be able to offload that work and not have to worry about scaling and deployment and things like that. There's many parts to serverless model. One that's pretty clear is something like auto-scaling. And so, if you have a data processing pipeline, whether batch or stream, and we'll talk about that in a little bit, the throughput of data going through the pipeline is not the same throughout the life of the pipeline, because a batch pipeline has different stages, or a streaming pipeline reacts to a varying stream of events coming in. And so, if you provision for peak, then you really, you don't really know what the peak is going to be, so you have to over-provision if you don't want to ever run out of capacity. And then you end up with idle resources. And so in a serverless model, one of the things that PubSub, Dataflow, BigQuery, all our serverless products do is auto-scale the workers such that at any point in time, you have the right amount of workers and no more than the right amount of workers. And what we mean by that is not auto-scaling within a cluster. It's global auto-scaling. Now, resources just go away from your perspective when you don't need them. And really allows those systems to be not just more reliable and faster, but solid and able to respond to your user demand very reliably. And so auto-scaling is just one aspect of serverless. There are many others, and you can see in the pie chart here on the left, some of the things that typically you as the user are responsible for in an on-prem big data system, or even a cloud system, which is not serverless. The hardware deployment might go away in cloud, but everything else in a traditional VM-based cloud system is the same, where you have to deal with deployment and optimization and performance tuning and just managing the infrastructure. In the serverless model, really all of that goes away. The only thing that's left is the part where you bring your expertise, your domain knowledge, your understanding of the data to get value from it without worrying about how the tool works and how to optimize your consumption and your availability. And so to hear that in practice, we can see a video where Spotify, one of our users, described how serverless has changed the way they process data and help them deliver better customer service.
The mission of Spotify is really about being a great musical companion and making it more personal. It's not going to be the streaming music experience or the online music experience. It's going to be your music experience.
We create the tools for people to actually swim in that sea of music data and find the information that really corresponds to why they're there.
Quite a while ago, we've made a decision to focus on data.
Depending on the complexity of the query, it could take a whole day. Sometimes it would have to run overnight.
And being able to store that and process that has been a very big challenge. Moving to Google's cloud platform enabled us to take use of the skill that Google can provide.
The reality is it's quite hard to build great data centers, and we saw an opportunity to spend our focus elsewhere. And that was really the driver into Google's cloud platform.
With Google Cloud Tools, we can rerun the same query, and it might take a few seconds, minutes.
The less time that we can spend solving problems that are already solved, like scaling our Hadoop cluster when Google has already figured out how to scale it for us, the more time and energy we can spend on turning our data into value. And that's really a game changer for us. When you're talking about a technology like BigQuery, when you're talking about data flow, you will feel the Spotify product evolve, making the user experience great.
Once you break down the data, you realize that there are nuances. It's not a straightforward path. It's a mosaic rich beyond the most popular artists. It's a lot more than that. Music can transcend boundaries of language, culture. If it moves you, then it's there, and it's there forever.
All right, so this was a very, very rewarding story for people in our team who work on those services and see them being used in practice. One aspect here that was touched a little bit as well is the move to stream pricing. Applications like Spotify are all about pricing events as they happen. And so a big part of that is using stream processing, in many cases a replacement for batch processing, which has been the de facto standard in the industry for most large data processing, to the point where it became almost intuitive to many people. And that's really something we have to unlearn, because in the real world, things don't happen in batch. Things happen continuously, and it's actually easier and much more effective to process things in that way and handle events directly as they arrive. And so we've built an entire portfolio of products throughout the life cycle of data, from the point of ingestion to support that, and to support use cases such as shopping and IoT and transaction, security, alerting. There's plenty of use cases across industries where time is money, literally, or even when it's actually not fundamentally something that has to happen right away. There really is no need to add the additional complexity of a batch pipeline, and we can just handle the events as they arrive and just provide quicker insight and not reserving stream processing to the most advanced use cases. It's now something that's available for everything, with services that cover the full life cycle, from the point of ingestion, where something like Cloud PubSub, serverless event delivery system, globally scalable, that can receive all the events, deliver them, to something like Dataflow, which is our serverless batch and stream pricing engine, allows the pipeline that you've written. Again, you've just written the logic of the pipeline. You haven't deployed anything. We'll run those in streaming mode into sources like BigQuery and like the ML systems that are available on the platform to do real-time prediction on this data. And so from start to finish, you can use fully managed serverless systems for stream analytics towards ML. And the architecture looks a bit like this, where obviously in many cases batch doesn't go away completely. It's a transition that takes time, and there are some data sources that fundamentally are batch oriented. And so you want to incorporate them, you want to support stream processing. What Dataflow gives you is, by offering a programming model that unifies batch and stream, allows you to write a pipeline once and have that pipeline handle both batch and stream. And as sources, typically batch sources become streaming, the same pipeline can keep handling them and then deliver them to downstream services for analytics with BigQuery and visualization and data science and machine learning, all in one well-integrated, easy-to-use platform. Another aspect of the platform is the fact that it brings the best of open source to Google Cloud, and you don't have to choose between fully managed cloud-native services like PubSub, like Dataflow, like BigQuery, or open source tools like Hadoop and Spark. You can mix and match the two, and we've made that possible by making Hadoop really easy to run on the platform, by making it really, really fast. We start a cluster from 0 to ready in under 90 seconds. You pay for it by the second, so it's very easy to use, very dynamic, and you can use it on the same data that BigQuery and Dataflow use. And so you can really mix and match the right tool for the right use case, all on the same platform. And then finally, one of the other key pieces of the big data platform on Google Cloud is BigQuery, our cloud data warehouse. And a way to think about that is to follow the evolution of data warehousing across the years. From the early starting point, on-prem data warehouses, move towards BI. Now kind of cloud data warehouses, where BigQuery is the kind of the shining example of that in terms of being serverless, having storage and pricing decoupled from the very start, very flexible model for cloud data processing, and the evolution towards more and more machine learning and AI, and BigQuery playing the role of being the data warehouse, which, thanks to all the work that Regin described that Google is doing on machine learning, will give you that access on your data, in addition to the traditional SQL-based access. And so, speaking of BigQuery, I would like to invite on stage Jordan Tigani, who is a tech lead on BigQuery itself.
Howdy.
Thank you, Jordan. I want to ask you a few questions about BigQuery, especially in the context of ML. And let's start with predictive analytics. Like, what does it mean? And in the BigQuery context, what are the use cases for predictive analytics that you see?
Sure. So anybody who's doing data warehousing can really take advantage of predictive analytics. It really lets you kind of take your analytics to the next level. You go from just being able to answer questions about the data that you know you have to being able to answer questions based on deep patterns within the data, or even data that you don't have. For example, you might not know what language your customers speak, and so you can apply machine learning algorithm to the Google Cloud Machine Learning API to determine which language they're speaking. Another big example that we see a lot of times with BigQuery customers is fraud detection. So they use known examples of fraud to build a model of what fraudulent activity looks like, and then they use BigQuery to analyze their logs and look for things that match that pattern. BigQuery is also a great place to do that because BigQuery allows you to combine data from a lot of different places, and often with fraud detection, you want to combine as many sources as signals as you have.
And so on that topic, technically, can you say more about what makes BigQuery so well suited for predictive analytics?
Sure. You have to look across the life cycle of how you do your predictive analytics. So first of all, you're going to need a place to store your data. And BigQuery is a great place to store predictive analytics data because generally that data is structured. And BigQuery is a great place for structured data. It allows you to manage your data life cycle, allows you to share your data with whomever you want. And then once the data is in, you need to understand it. I mean, that's a big part of any kind of prediction process is developing a feel for your data. And BigQuery has strong connections to a bunch of BI and visualization tools. Our own Data Studio, but also Tableau and Looker are great ways to get a feel for your data. And then you're going to want to transform your data. So you may have to clean up the data. You may want to look at outliers. You may want to apply some statistical resampling to your data before you're ready to actually do the prediction. And then finally, BigQuery has excellent integration with tools that data scientists are using already, such as R and Pandas, and there's Google Cloud Data Lab and TensorFlow as well.
Okay. What about streaming? I know just earlier I was describing the move to streaming analytics. How does Google Cloud support that in the case of predictive analytics?
Sure. So, as you mentioned, that streaming is a use case that Google Cloud is really focusing on, and I think people want to reduce the time to their time to insight. So instead of just being okay with daily reports or even hourly reports, people want to know what's happening up to the minute or up to the second. And so there's an architecture of a bunch of Google Cloud products together that can make this work extremely well. So you may have your events being generated either from sensors in a factory or a pixel beacon on your web page, or perhaps transactions from your stores around the world. You send those to Google Cloud PubSub, which gives you reliable global message transport. You process those with Google Cloud Dataflow, which allows you to kind of transform the data, and then you can send that to Cloud Machine Learning Engine to maybe apply a demographic model or one of the Google Cloud APIs, machine learning APIs, to do language detection or sentiment detection. Then finally, you can stream it into BigQuery, which the whole time taken by this process is generally less than a second. So the queries that you run then can combine kind of predictive analytics and prediction. But they're really up to the second.
Okay. And you talked about those streaming sources, from IoT, from application streaming into BigQuery. What about application data? How can people bring their application data in their enterprise application to BigQuery?
Sure. So that depends on where your data comes from. Getting data into BigQuery, as we know, is super important because if you can't get your data in, then you can't actually analyze it. So one big class of data is the streaming data. We believe that all large data sets are generated over time, so we want to make streaming work as well as possible. And BigQuery streaming and instant availability is a large class of data. There's also data that Google already has. So this could be AdWords data or DoubleClick for publishers, Google Analytics data. And Google Transfer Service allows you to automate ingestion of this data automatically into BigQuery. You may also have data sets on-prem or data sitting around that you want to get into BigQuery, but you don't quite know how to do it. And data prep is a tool that we have that allow you to do schema transformations and to generate a pipeline that will help you move that data into BigQuery. And there's a final category, and that might be data that could be in an enterprise app or a SaaS application, and it's more tricky to move into BigQuery. And so we've got a number of integration partners like Informatica and Talend that will help you get that data in.
Okay. And so speaking of how BigQuery, in addition to providing analytics and dashboard and traditional analytics, also support the move to ML, how can BigQuery be used to prepare data for model development?
So pre-processing is A, one of the hardest, and B, one of the least satisfying things for data scientists. I think I saw somewhere that 3/4 of data scientists said that data pre-processing was their least favorite part of their job. BigQuery makes it really easy. You just you write a SQL statement and you hit query. There's a kind of a traditional way of doing ETL, so extract, transform, and load. And the last part is sort of in your database. BigQuery makes ELT possible. So you get the data in, and then you do whatever your transformations you need in BigQuery just in SQL. It should be really easy, and if you can't figure out how to do it in SQL, we also have user-defined functions that will help you kind of do things that may be more complex. And finally, BigQuery makes it easy to share both queries and data sets. So once you figure out the transformation that works, you can share it with your coworkers or colleagues, and so you can kind of productionize the best practices.
All right. Thank you very much, Jordan. We're going to take a very quick break, and we'll be back for a panel. Thank you.
Hello and welcome back to Cloud on Air. You're live with us here in London. I'm John, I'm your host for today. I'm joined now by some of my cloud colleagues, and I'll introduce them to you. We have Omer Khalid to my right here. Omer is a machine learning consultant. We have Rich Radley next to Omer. Rich and I are opposite numbers effectively. You can almost tell that because we apparently are wearing the same shirt today, more by accident than by design. And we have Khalid as well, and he is a machine learning specialist. So we've taken some of the questions that you have submitted. We have a panel here where we can go through with these guys and actually answer live and in person some of the questions that you have asked us. So just starting, Omer, with you, if I may.
Sure.
Some of the questions coming through were saying, look, you talk about artificial intelligence, machine learning, data mining, big data. What's the difference between that stuff? Can you help us with that?
That's a great question, John. And these terms are being used in so many different ways, and I think it's really good to kind of get into it. So big data or data analytics is really about driving structured analytics from structured data. Let it be your databases, could be your files or whatever. And whenever you can actually program in a linear way, say, hey, A plus B is equal to C, that's your structured analytics coming from big data. But then to do a lot of data, and William was talking earlier on the keynote, that a lot of organizations, they have huge amounts of unstructured data, and that's where AI really comes in, which is artificial intelligence. It's really about how does the computers can learn and mimic the behavior of human brain and solve problems. But then it's really, really complex to code, and that's where machine learning comes in. It's really the application of that AI bit, making sure learning from the data which is there and being able to predict and apply to data which you haven't seen. So that's how I think I would see it and say it.
Okay, so big data is the structured, artificial intelligence for unstructured, and machine learning is actually finding ways to look at it. Okay, thank you. Now, Khalid, if I come to you, if let's say I am an experienced developer and yet I am new to artificial intelligence, new to machine learning. Where do I start?
Getting started to machine learning AI has two aspects, the learning aspect and an applying aspect. As for the learning aspect, I recommend to start with understanding what kind of problems that machine learning AI can help you to solve and relate these kind of problems to your own business use cases. Second is data. Since data is a key element to successful machine learning, it's very important to be comfortable with working with data. That is doing data wrangling, data processing, data visualization, and so on. Then I recommend to play with some of the simple, easy to use machine learning libraries such as scikit-learn to build toy models just to get comfortable with the process of model training, model evaluation, and prediction. There are several data science and machine learning tracks online that can help you through this journey, including our data engineering track on Coursera. So this is regarding the learning aspect. As for the applying aspect, I recommend to pick one use case that is relevant to your business domain. Make sure that you understand the problem properly, set your objectives up front, then collect the data that is relevant to this use case and try to apply your learnings into how machine learning can solve this particular problem.
Okay, so start with something, a use case you really understand before trying to do something even more evolved than that. Okay, thank you. And Rich, you do a huge amount of work with financial institutions.
Indeed.
Many times when I talk with financial institutions, they will say, look, from a compliance perspective, there's stuff about keeping our data locally, as in the country. Maybe we can't move it out to the country. Cloud computing, of course, maybe it does need to move out to the country, or maybe we can keep it locally. Can you just help understand, if I'm a financial institution, how would that affect me in terms of moving data and being able to use a cloud service like Google?
Sure, it comes up a lot, as you'd imagine. So I think there are two aspects to Google's philosophy and approach around machine learning in the cloud. Firstly, obviously we're providing the data sets, the databases, and the cloud computing resources to make training and then using a machine learning model in production more efficient than it's been previously. The other aspect is open sourcing the software that we use internally to train machine learning algorithms, develop machine learning algorithms, so you can run them not just in our cloud computing environment, but elsewhere as well.
Right.
So what we're doing is working with financial services institutions to help develop a representative data set for training that can be run in the cloud, so looking at masking techniques, etc., to create a data set that can be used as the basis for training a model, using cloud computing resources then to train that model in the first place, but then taking that model, running it using technologies like TensorFlow on-premise or in a facility that's outside of the cloud environment, so that you can overcome some of these data locality and jurisdiction issues. And of course, the other thing that we're doing aggressively at the moment is rolling out new data center locations. So, increasingly this year and through 2018, we're going to see more and more data center locations being available. So again, there's more choice when it comes to running, cloud computing resources in some of those locations.
Right, so effectively train it then using the cloud technology, and then if you need to, run it locally using some of the open source.
Absolutely.
And by the way, actually lots more data center locations and regions opening.
That's right.
Okay, thank you. And we talk a lot, we hear a lot about big enterprise organizations, and yet by volume, we've got around about 28,000 people who've joined us from across Europe, Middle East, and Africa. Thank you for joining. Most of those people will be from businesses that are not enterprise size. So if somebody's joining from a smaller organization, from a mid-sized business perhaps, how do they start getting into machine learning? Omar, could you help with that?
Yeah, sure. I think this is great because for larger organizations, it's a lot easier because they have lots of data and they have skills in-house, right? They have lots of developers who might have be skilled in being as data scientists or researchers.
Yep.
Whereas for smaller organizations, the challenge is, as Rich mentioned about models, and Khalid talked about a little bit about the models and the kind of things they can develop, that how you can actually start early. So we are solving that problem for them, basically. So if you look at all the pre-built models we have made available via our APIs, let it be speech, vision, video intelligence, natural language API. So if you're a small business, you have the data, you're building products, or you're providing a service where you just say wants to do some sort of sentiment analysis. All you need to do now is write a few lines of code, plug into our APIs, and then being able to provide those insights right to your customers. I think that's where really we are democratizing the whole process of accessibility to ML and reducing that barrier so that everybody can access it and utilize that.
Okay, so just a few lines of code and plug into the APIs. It really is as straightforward as that if people want it.
Absolutely.
Okay. And Rich, you were talking about running things on our service, such as TensorFlow, machine learning, for example. Are there any advantages to running this on Google Cloud Platform? Perhaps Rich and or Khalid can help with this?
Yeah, why don't you start?
All right, this is a good question. TensorFlow is an open source framework that can run in different platforms. However, there's a number of advantages to running TensorFlow on GCP, including scalability, productivity, as well as performance. So imagine that you want to train a TensorFlow model at scale. That means you have a big TensorFlow model, you want to train it on large data set. So that means you need to run it in a distributed fashion. So you need to create a TensorFlow cluster, maintain this cluster, scale this cluster if needed. On the other hand, we have Cloud Machine Learning Engine that is serverless, no operation service that takes away the headache of the infrastructure, so that improves scalability.
Okay, thank you. I'm going to have to cut it there to say we're about to go now to the live streams that we have available. If you look on the top left of your screen, you will see the agenda and you can choose which stream you have. We have industry solution agenda. We have one stream which will be about machine learning and artificial intelligence, and another which will be about big data. So you can see those up on the top left of your screen. If you then look on the top right of your screen, you will see you've got an option to click and select any one of those three as you wish. So please do that, and we'll see you back here shortly. Thank you.